Next, let's take a look at some basic functions of OTUs. OTU stands for Optical Transponder Unit, which is a term we use in our company. Some peer vendors or operators also call them transponders. As shown in the figure, the key function modules of an OTU are the client-side interface unit, line-side interface unit, and intermediate electrical layer, 3R processing unit. An OTU provides three main functions. The first is the conversion of gray signals from the client side into colored signals. Gray signals usually have large spectral widths, resulting in one signal taking up one fiber. However, WDM wavelengths have relatively small spectral widths. In an 80 wavelength WDM system, the spectral width of a WDM wavelength is only 0.4 nanometer, and therefore multiple wavelengths can be multiplexed into one fiber using the multiplexer unit. The second function of an OTU is the 3R processing, retiming, reshaping, and regeneration. In this figure, there is an important demarcation port, which is the optical port at the client side. On the left of the port, there are client devices such as IP and SDH devices. Once a signal enters the optical port, it has entered the WDM network. This port is a very important position for demarcating faults and maintenance responsibilities. Operators assign various departments to be in charge of different devices or networks. For example, an operator may have IP, access network, and WDM departments. Different departments are responsible for the maintenance, provisioning, and fault locating of different network devices. Therefore, the client-side optical ports on WDM OTUs are important fault demarcation positions between WDM networks and other client-side networks, such as SDH and IP networks. The figure shows a more detailed functional composition of an OTU for professionals in the WDM and transport fields. An OTU is composed of client-side optical ports, WDM-side optical ports, and intermediate electrical layer OTN processing, FEC processing, and modulation. Let's now have a look at some OTU categories. We generally categorize OTUs into transponders and Muxponders, according to different wavelength rates on the client and WDM sides. The most significant feature of a transponder is that the wavelength rate on the client side is at the same level as that on the WDM side. For example, if the client side signals are 10G or 10GE signals, a transponder transmits them into 10G channels on the WDM side. If the client-side signals are 100 GE signals, a transponder transmits them into 100 G channels on the WDM side. A Muxponder, on the other hand, multiplexes signals with a lower rate into higher rate channels. For example, a Muxponder multiplexes 10 10G signals into one 100 G channel, or 8 GE signals into one 10G channel. One common feature shared by both transponders and Muxponders is that the client-side ports and WDM-side ports are integrated on the same board. Finally, let's look at some WDM application scenarios. One common application scenario of WDM systems is the open system. An open system uses OTUs on a WDM device to convert gray signals from client-side devices into colored signals. An 80-channel WDM system generally requires 80 pairs of OTUs. Such an open system is the most common application scenario, accounting for over 90% of the applications. The main characteristic of an open system is that it helps operators make invitations for bids based on different equipment types. In addition, open systems also support fast locating when a fault occurs. Suppliers are also in favor of this application scenario because the capacity expansion of wavelengths requires operators to purchase new OTUs on which the expansion will be implemented. The other scenario is the integrated system, which is rarely applied. In an integrated system, the client-side device directly outputs ITU-T standard-compliant colored DWDM signals, and the WDM system provides only optical layer functions, such as multiplexing, demultiplexing, and optical amplification. This application occupies only less than 10%. The integrated system is promoted by Cisco but is not recognized by mainstream operators. The key factor is that integrated systems allocate the function of an OTU, converting gray signals into colored signals, onto routers, causing difficulties in fault locating and supervising the quality of electrical signals in each channel on WDM devices. Well, that's all for this course. Let's have a quick recap. This course mainly covered the following aspects: the position of WDM in the communication network, compositions and application scenarios of backbone and metro networks, composition of WDM devices, functions and classifications of OTUs, and application scenarios of WDM systems.